Greetings to Dr. Hafiza and fellow examiners. We are Group 5_6 who are representing about the Global Research Conference Management System. Before please allow me to introduce our group members who are Chien, Sivanashni Chandran, Sherlyn, Joey, me, Yuanming, and Wei-Le. In our video, we'll be talking about the background of our database, followed by the attributes, data type, and constraints. Next, we'll be talking about the queries as well. And last but not least, we will run the script one time and conclude our video today.
So right now, I will start to present our database system, Global Research Conference Paper Submission and Review System, also known as GRCMS. GRCMS was developed. It was developed as a centralized database system. It helps organizers manage conferences more efficiently and also ensures the data is organized, consistent, and easier to access for all. Next, I will give a brief overview on our system. Firstly, the conferences will be registered into the system, including details such as the conference name, location, and the duration. After that will be the author's registration. The participation of the authors in conferences and papers will also be tracked using bridge tables such as conference author and paper author tables. After that will be paper submission process. After the papers are submitted and stored in the system, there will be reviewers assigned to evaluate the papers. Reviews, including scores and comments, will also be in the system to ensure fair and structured evaluation. So, what are the benefits of this system? With GRCMS, the organizers can easily access review information, monitor reviewer consistency, and manage conferences more effectively. Overall, this system improves efficiency, fairness, and transparency in the conference review process. In conclusion, the system simplifies the management of the research conferences and supports high-quality academic evaluation. Thank you.
Hi, my name is Sivanishni Chandran. For this part, Sherlyn and I will walk us through the heart of our database, the attributes, the data types, and the constraints. Our system is built around 7 core entities to ensure a comprehensive flow from the conference setup to paper review. We have institution, conferences, author, reviewer, and paper review. To maintain data integrity, we carefully selected data types for our attributes. For numeric IDs, all the primary keys such as institution ID, author ID, paper ID, we use the numeric data type to ensure unique and efficient indexing. Varchar 2 for text. For names like emails and names like author name or author email, we use variable length string to save space while accommodating long entries. As for the data format, field like start date, end date, submission date, we use date data type, allowing us to implement logic like ensuring a conference doesn't last more than 10 days. Precision scoring. In the review table, the score is defined as numeric to 1. This allows for scope up to 10 with 1 decimal place, meeting our business rule for precise evaluation. As for the Crowdfoot notation and relationships, we have one-to-many. You will notice a 1-to vertical line at the institution end and a Crowdfoot at the author and reviewer ends. This signifies that one institution can have many authors or reviewers, but each individual is linked to only one institution. We also have mandatory versus optional. For example, the relationship between paper and review shows that a specific review must belong to exactly one paper, which is mandatory, but a paper can have 0 to many reviews. One of the most critical parts of our design was handling many-to-many relationships. In a relational database, you cannot link two tables directly if they have a many-to-many relationship without causing data redundancy and anomalies. We identified two major many-to-many gaps. Firstly, author and conferences. An author can attend many conferences and a conference hosts many authors. To bridge this gap, we created a junction table. This conference author table resolves the many-to-many relationship by holding composite primary keys from both paper ID and author ID. We have conference author to ensure we can track an author's involvement across multiple conferences without repeating their personal data every time they register for a new event. Next, we have authors and papers. Many authors can collaborate on one paper and one author can write many papers. We have created paper author as a junction table. This bridge ensures our database remains in the third normal form, 3NF, maintaining high data integrity and efficiency. That is all from my part. Thank you.
To guarantee fairness and data integrity in the Global Research Conference Management System, we have implemented 10 critical constraints. These rules eliminate logical errors, standardize evaluations, and ensure a seamless user experience. Starting with institutions, every institution name must be unique and not empty. This prevents data fragmentation and ensures accurate reporting by avoiding duplicate entries for the same university. For countries, we require a minimum of 2 characters and restrict symbols to hyphens and periods. This validates entries like UK while rejecting invalid symbols or numbers. Moving on to conferences, locations must be at least 4 characters long and contain no numbers. This ensures meaningful city names like Rome or Tokyo. Next, we set a year 2025 floor for the start date. This prevents accidental entry of outdated historical data. Finally, the period check ensures a conference cannot end before it starts and limits the duration to 10 days. This prevents scheduling errors and reflects the reality of international events. Next, we have the authors and reviewers, where their email addresses must be unique across the system. This maps one email to exactly one account, preventing data collisions or login confusions. Every email address must also follow a standard structure, which ensures that we do not store fake contact information. Lastly, in the review table, review scores are strictly limited to a range of 1 to 10. This prevents fat finger errors and ensures that every paper is evaluated on the same scale. To ensure authors receive helpful feedback, we require a minimum of 10 characters for comments. This prevents reviewers from leaving vague comments that doesn't help the author improve. Finally, we have the unique reviewer check, which prevents a single reviewer from submitting multiple reviews for the same paper. This is crucial for maintaining a fair, unbiased, and transparent evaluation process. By combining these 10 constraints, the GRCMS ensures that all data is accurate, logical, and ethically handled.
This query produces a paper-centric list that shows every paper in the database, even those that have no reviews yet. It displays the corresponding review IDs and scores. The goal of this query is to avoid hiding new or unreviewed submissions, so stakeholders get a complete picture of the submission landscape, with reviewed papers showing their scores and unreviewed papers appearing with an empty, null review feed. The query selects paper ID and title from paper, and then left outer joins the review table on paper ID. A left join returns all rows from the left table, which is paper, and matches row from the right table, which is review. If a paper has no reviews, the join review columns, which is review ID and score, will come out as null. Finally, it is ordered by the paper table, paper ID, and the review table, review ID, that ensures that the papers are grouped and reviews, if there is any, are listed in a stable order. So this query provides an evaluation view for authors by calculating the average review score across all the papers each author has contributed to. It's designed to summarize performance at the author level, so teams can quickly compare how different authors and co-authors fare on average, even when some of their papers have not been reviewed yet. For those papers that have not been reviewed yet, you'll just see a null average until a review exists. First started with the select author table author ID and the author table author name, which is then followed by the aggregate function of average review table score, which computes the mean across all available review scores, and round 2, which formats the value to 2 decimal places. The query is then continued with a from author and joins paper author to link authors to paper. It then joins paper for context and left joins reviews so that papers without reviews don't exclude the author from the result. So this query pinpoints AI team submissions that were submitted in March. It is useful for time-boxed reporting or trend spotting, allowing organizers to focus on seasonal intake, specifically papers whose titles reference AI and whose submission dates fall within the month of March. Query filters the paper table with 2 predicates, title like AI, which ensures only papers whose title contain the substring AI are included, and a date to month check limits results to March. So in my current script, this is implemented with a tochar submission date equals to 03, which converts the date to a 2-digit month string and compares it to 03. It is then followed by author by submission date, which presents the list chronologically within March. So this query assembles a list of reviewers based in Malaysia who have expertise in AI or machine learning. It's intended to help assign appropriate reviewers to AI-related papers by combining location with skill filters, ensuring local expertise is easily identified for relevant conference track. Joins the reviewer table to the institution table using the institution ID column so that we can access the country information for each reviewer's institution. In the where clause, 2 conditions are applied. The upper reviewer table expertise like AI or upper reviewer expertise like machine learning, which ensures that only reviewers whose expertise includes AI or machine learning are selected. The upper institution table country is equals to Malaysia, which restricts the results to reviewers affiliated with institutions located in Malaysia. The use of upper in the condition standardizes text to uppercase, making the comparison cases more insensitive. Finally, it is followed by an order by reviewer table review ID, which sorts the output by review ID for consistent listing.
Now I will explain about Part E, which is finding authors who have published papers in Asia conferences, particularly Tokyo, Singapore, and Seoul. So the purpose of the query is to find active authors, and for these authors, they can build connections with each other, and for conference organizers, they can find these authors to present in their conferences. So the result table is expected to have author ID, author name, and author email for contact details. So how does it work? First of all, is that the first subquery, which is at the bottom, is to find the conferences in Tokyo, Singapore, and Seoul from the conference table. The next subquery will find the paper presented at these conferences from the paper table. After that, the paper author table is used to find which authors wrote these papers. And finally, the main query shows the details of these authors. And next is about the part F, which is to find consistently generous scored reviewers and their above average review papers. So there are two purposes here. We have to find reviewers that score a high marks. So here we set a minimum of 8 for all review papers. And second is to filter papers with review score above the overall average score. So the result table is expected to have reviewer ID, reviewer name, and their paper ID, title, and score as well. So it's split into two purposes here. So how does this work? First of all, this query has joined and connected the reviewer, review, and paper tables. An extra join on the review table is used to check all scores given by each reviewer. There's a condition of minimum of 8 to ensure that the reviewer never gives a score below of it, as listed at the purpose 1. Another condition is to check whether the paper is above the average score, as listed at the purpose 2, using the AVG subquery. Okay, and finally, the results are ordered by their reviewer and paper ID so that they are easy to read.
Now I run through the code and conclude the database. After we created the tables and inserted the data, as shown before this, we executed the select statement to display the content from each tables. These queries allow us to retrieve and view all the information stored inside our database. I will now go through each tables. So the first table is the institution tables, which shows the universities and institutions along with their countries. Next is the conference tables, which contains conference details like names, location, and date period. The third table is the author table, which lists down authors and link them to their institutions, expertise, and also their email. Next is the conference author table, which serves as the linking table between conference table and also the author table, as one conference can have many authors and one authors can join many conferences as long as they do not clash with one another. Next is the reviewer table, which stores reviewer who evaluate submitted papers along with their expertise and their email. The sixth table is the paper table, which contains all submitted research papers along with which conference they belongs to, and also their the title, the abstracts, and also the submission date. The next table is the paper author table, which is another bridge table between paper and also the author table, as one paper can have many authors and one author can also have many paper. So this table shows the authors for each paper. And the last table is the review table, which shows the evaluation results for each paper, including the score, comment, and also the review date. So from these outputs, we can confirm that the data was successfully inserted and the relationship between tables functions as expected. Additionally, we can see that the data inserted is diverse, with authors and reviewers coming from different universities and countries, and conferences hosted in various global locations. This variation helps reflect a realistic international research environment. So in conclusion, our Global Research Conference Management System database provides a centralized platform to manage international academic conference more efficiently. It handles institutions, conference, author, reviewer, and papers and reviews in a structured way. This reduces manual workload and increases fairness and transparency in paper submission and review processes. It also maintains data integrity through primary key, foreign key constraints, and validation rules.